I guess you can see the chat too, so I'll close that. Okay, so welcome to the beginner workshop. So this is for anyone that's very new to game development, or for artists that haven't really messed with GitHub before. And so let's just go over what we're going to do today. So if you saw the announcement, this is basically what I said on there. But just to reiterate, what we're going to be doing is we're going to fork and clone the project repository. We're going to open that project using Unity. We're going to add like a dummy file just to show that how we can make a change to the project. We're going to then pull commit and push our changes. And then we're going to make a dummy pull request, which is how you're going to actually contribute to the final project. And then as a final thing for programmers, I'm going to implement very basic movement in the game. And so basically everything up to the very last bullet point is useful for everyone that's contributing, whether you're an artist, a designer, or whatever, a writer. This is basically how you're going to make changes to the project. And the very last bullet point is for programmers specifically. And so if you want to, you could leave before the last one and just get this important part out of the way. So yeah, let's get going. And so before we start, I want to give like a very high level overview of what exactly it means to fork and clone a repository, what a repository is, what is GitHub. Because when I was a freshman and I first started getting into game development, this is all very new to me and I had no idea what was happening. It took me a little bit to quite understand what exactly the tool I was using was doing. And so this is a very high level understanding. So what is GitHub? GitHub is basically just a service that hosts projects. And we use it for something called version control. And so it's just a way for multiple people to work on the same project. And so if you look at this diagram, this repository here, this server, that is GitHub. Okay, they're just computers hosted by GitHub, that owned by GitHub, that hosts our services. And so we, as contributors, are these workstations down here. And so what's going to happen is the repository is where the project is. The GitHub link that's on the server and is on everywhere. That's this thing. What we're going to do is we're going to clone it, basically make a copy of it on our computer, make changes to the computer, to the project, and then push our changes to the repository, which is like the final version. And then other contributors can pull your changes onto their computers and then push their changes, and then you can see their changes by pulling, and that's how it works. We basically have a copy on our computer, make changes, push it to GitHub. Other people push their changes to GitHub. We can then pull their changes, and it just repeats. And that's how many people work on the same project. But now to go even more specifically into what we're going to be doing, we're also going to be forking the repository. So this is what it means to fork. This yellow thing, that's the project repository that is linked everywhere that I mentioned earlier. We're going to make a fork, which is this red thing, and then we're going to clone that fork. And so what's happening is this is still on GitHub. This is still a project that's hosted on GitHub's computers. Instead of cloning the actual project directly, we're going to be making a fork, which is a copy of that project, and then making a copy of a copy, basically. That way you can make changes, do whatever you want to this, without accidentally bringing in a bug or an issue into the final version. And then after you make your changes and you want to push it into the final version, we'll go over how you can make a pull request, which I mentioned earlier, which you basically ask us, hey, could I pull my changes into the final version? And then we'll check your changes, make sure there's no problems, and we'll be like, yeah, no problem. Or we might be like, could you make a change here? Or like, this might be a problem. Could you do something else? And then you can make your changes, and then we can accept your pull request. And that's basically what's going to be happening in like a very high level understanding. And now that we went over that, let's like actually do it. So you guys can see my whole screen, right? It wasn't just Chrome. So if I like pull up Firefox, you can see this.
Yeah, we can see it.
Okay, sweet, thank you. So I made a dummy account on GitHub, and I'm just going to show you guys the whole process. So you guys should all have a GitHub account. Hopefully you do. And so you'll go to the project repository. I can put this in the chat if you want to follow along. So you go to this project repository, and then you'll go up here in the top right, and you'll click fork. It's going to give you this little diagram thing, this little menu, and you're going to create fork. And now you have a copy of the project as your own personal repository. So now you can make changes and do whatever you want to this. But now to actually make the changes, you have to bring it onto our computer. And so you're going to click code up here. And you're going to click this is to copy this link. And so you'll copy this link. And then we're going to use something called Github Desktop, which I think I forgot to mention in the announcement. But this is basically a piece of software that allows you to interact with GitHub and just any Git repositories. So if you can download this, that would be great. But yeah, that's what I'm going to be going over, how to interact with GitHub today. And so you'll copy this link. You'll open GitHub Desktop. That's what it looks like. You go to the top left. You press clone repository. You'll go to URL, paste that link there, and you can choose where to save it. I'm just saving it in like a random folder. And then you click clone. Sweet. Now if I go to that folder, oh, I don't know what happened there, but if you go to that folder, I saved it in workshop testing. This is the actual repository that I saved. This is everything that is on GitHub is now on my computer. So yeah, here's the game. And so now that we have that on our computer, let me show you guys how to open it with Unity. Sweet. So if you went to the link that I sent in the announcement, it should have taken you to a place to install the Unity version we're going to be using. And it should have had like the first link was installed with Unity Hub. So this is Unity Hub. It's just a way to have multiple versions of Unity. And so to open our project, I'm just going to click open. And you're going to have to find, oh, why is it so small? You're going to have to find the folder where it's saved. And then this is the repository we saved or cloned to our computer. We don't actually want this folder. The actual game is this folder right here. And so you open this folder, and then this is the actual folder you want Unity to use. And you'll click open. And there it is. It'll be figuring it out, and it should open. Okay, now we have to wait a little bit because Unity takes a little bit to open projects. Does that make sense for everyone so far? Cool, I'll take that as a yes. So once Unity opens, I'll go over how to make a change, and then we'll push it onto our fork, which basically means we're going to put our change on GitHub as well. Let me make sure nobody's trying to get in. Okay. Is anyone here completely new to game development? Like this is the first game development project you're going to be working on? Okay, sweet, sweet. Okay, cool, 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 cool. It's going to feel a little daunting. There's a lot, especially in a project like this, but I feel like you're going to learn a lot. Sweet, sweet. Oh, it's okay. It's good to see new people. You want new people. Are you guys UT students? Oh, okay, sweet, sweet. Ah, okay, okay, okay. Are you guys freshmen? Oh, we have some freshmen. Okay, no problem, no problem. I'm also not a freshman. Oh, okay, okay. Sweet, sweet. It's cool to see people getting interested in game development. Oh, nice. You're going to your last year then? That's exciting and also a little bit emotional. Oh, okay, okay, okay. Nice, nice. But almost done with undergrad, so that's the thing. I'm going into my junior year, so I still have 2 more. Yeah. Nope. Sweet. Here's Unity. For anyone new to Unity, this is going to look very daunting because it looks very daunting to me too. But let me run some things down, okay? This right here is where you're going to make changes to the game. This is like an editing view, okay? It's called the scene. This is where you can drag in objects. This is where you can, yeah, basically drag in objects which has properties like your player, your camera, make objects and such. And then this game is what the game actually sees. This is what the camera is seeing right now. So this is what the players will actually see. So this is where mostly you're going to be messing with the scene view. And then this hierarchy is just a list of everything in the scene. So if I were to like right click and create a circle, you saw that I can see a circle in the scene. I can move it around, but it also says it here on the left. So this is just a list of everything in the scene. And if I go to game view, you'll see a circle. Wow. That's the top part. And then down here is just a file explorer. Same as like your operating system, just a regular old file explorer. So if you know how to use a file explorer in your regular operating system, you can do this. And then this inspector on the right basically gives you properties about the game objects you select. And game objects are just basically anything in the hierarchy of the game object. So if you look over here, this is just a bunch of properties about this circle game object. It's a sprite because it has an image, and every game object has a transform, which is basically its position, its rotation, its scale. Cool. So now that you know kind of what's everything on the screen at a high level, let's make a change. So there's a bunch of pre-made folders in this project so that everything can be organized nicely. If you want more information about these folders, it's in the contribution standards, whatever it was called. It's one of the important links. We have contribution guidelines, and then we have contribution standards, something like that. And so it'll tell you all about where you should place folders, where you should make new folders. Basically, you shouldn't make a new folder in this assets folder, this big assets folder, but you can make subfolders within any of these. And so the dummy thing that I'm going to put into this project is just a piece of art that I made for this. So let me go into the art folder. Let me go here. This is where I saved it. Let me just drag it in there. So there's our art. There's my art that I obviously made. And now that I made a change to our project and I save it, if I go to, oh, okay, it gave me a dummy scene. So if I save the scene, it's going to ask me where to save the scene. So let me go to scenes, testing scene. Okay. So basically a scene is like almost like a level in a game. So you can split up different levels. So a scene just has a bunch of game objects in it. So if I go to assets and I go to scenes, there should be an example scene already that comes default with Unity. And so if I go to that, it should be different from the one that I put a circle in. This is the one I just made, by the way. Okay, so now that I made changes to our project, if I go to GitHub Desktop, you should see some. That caught me off guard, but you should see some changes. And so that was the change I added. And this is just the scene I made and stuff. And so this is all the changes I've made to the project. And so to the next step will be to commit your changes. This is a local thing. It's happening on your computer. It's basically a way to make sure if I make a mistake, oh crap, I broke the game. I know it's almost like a save point. I made a commit beforehand. I can go back to, and I know that's working. So it's good to commit often. Every time you make a change, it's a good idea to commit. And so it won't make a change on the GitHub server, so like the final version, but it will make a change on your computer. And so let's commit these changes. The thing you have to do when you commit is you have to give a summary. It's almost like a header, like, hey, what is a very short summary of what you did? So let's say added important artwork. Cool. If you wanted to, you can also add a description, optional. Sometimes I add like bullet points of like certain features I did. But this is mostly important. I don't always add a description. And so now we can commit. It'll think a little bit. And now I've made a change on my computer. So if I go to history, you can see all the changes that were made to this project beforehand. And now your change that you just made. But if you notice, there's a little arrow here, and an arrow over here as well. That means that you can push this commit to the actual server on GitHub, specifically your fork, because we made a fork, right? So it's like a copy of the actual repository. And so we're going to push these changes onto our copy. So let's go over here. Let's press push. It'll think a little bit. And bang, now it should be on GitHub. So if we go here, this is the repository website or our fork. If I refresh the page, you should see now there's this change that we just made is mentioned here. And if you go to the game, you go to the assets folder, and we go to art. There it is. There's the art we just added. But now let me mention something else. If you remember when I was talking about committing and pushing changes, I also mentioned pulling, but I didn't pull anywhere just now. So pulling means bringing any changes that were made to the server since I last pulled, basically, since I last made a copy. But no changes happen because nobody else is working on my fork. But let's say you want to work with a group of friends, or there was a change in the actual repository, and I want to make sure that my work is up to date so that when I start working, I'm not missing any features that the final game should have. Oh, is there any question? Thank you. Yes, it's very important artwork. But yeah, so I should probably pull those changes so that when I'm working with the most up-to-date version of the project. So let me make a dummy change on this project here. So if I make a change here on GitHub, the website, it's as if somebody made a change on their computer and then push it onto the server. So basically it means it's on the server, but it's not on my computer. So let me just make dummy change. Cool. I just made a dummy change to my fork. So if we go down here to the README, cool. And now if I go to my GitHub desktop, I can click here to fetch. So it'll basically look at GitHub and be like, huh, is my version up to date with the one on GitHub? And it's going to be like, oh no, it's not. I can pull. So now I can pull those changes. So in a real life scenario, somebody else made a change on their computer. They committed it and then pushed it onto GitHub. And then I pulled those changes onto my computer, if that makes sense. Cool. And so that's kind of the workflow. And now I could go back to this, make a new file or something. Save my changes, go to GitHub, add a commit, and then push my changes. And you can make multiple commits. So like you can do a bunch of, like I'm working on a feature, I'm working on a system, I'm gonna make a new file, the file is working, I'll make a commit. I'll make my next file, make a commit. And then I have a bunch of commits and I can push them all at once. So you don't have to be pushing all the time. You can if you want to, but most people usually like make a bunch of commits while working on a feature and then push it once the feature's done, if that makes sense. That's kind of the workflow. So that's kind of what everyone's going to be doing, not just programmers. So you saw that I added artwork. So if you're adding artwork, you're adding music, you're adding dialogue, you'll bring in your files, save the project, go to GitHub Desktop, commit your changes, push it onto the server. Cool. Does that make sense so far for everyone? Okay, I'll take that as a yes then. Okay, sweet. But if you remember now, when we push these changes, we're doing it on a fork, which is a copy of the actual project. It's not the actual final project. So what if we wanted to bring these changes into the actual final project? So if you go down here, this is the actual repository. This up here is the one we're on right now, the website, which is a fork, but this is the actual final repository. So if I go there, I can go here to pull requests, and I can create a new pull request. Oh. Cool. So now that I'm here, I can choose, why isn't it showing? Oh, okay. I gotta compare across forks, sorry. Click this. And so now you can change, you can choose from my fork, I'm gonna bring in these changes into the final version. So this is the final version, the equivalent one. Oh, crap. But I want to bring it in from my testing one. So it's going to go from my testing fork into the main one. Cool? Make sense? And then I can create a pull request here. Long. And this will basically be some questions that you have to answer to explain what changes I made, how did I, or what problem I was addressing, those kind of questions. And there's also for bug fix, like say you fixed a bug, you can this question specific to bug fixing. So this is kind of to give more information to us, the team behind the actual final project, to make sure we understand what exactly you did. Because we can also look directly like at what changes you made. But sometimes it's a little confusing. So it's good to have some summary and some idea of what we're looking at. And so this is what that's for. And then you also need a title. And so you'll do some things and you'll create a pull request. I won't actually create one now because it would, yeah, we just have like guidelines saying that we shouldn't make pull requests for just testing because it'll just bloat up our pull requests. Yeah, so then we have to go through pull requests that don't actually matter. By us, I mean the team at EGaDS that's working with the repository. But if I were to actually make a real change, I would actually answer these questions. I would make a title and I'd create pull request here. And then what you do next is just wait. We at EGaDS will look through your pull request, make sure you're not bringing in any actual accidental bugs, that you actually are fixing a problem that we need to solve. And if there's any changes, we can make comments on your changes. And so you can go check your pull request later. You might see like comments similar to Google Docs, where it highlights what the thing we're talking about. And then it has a little comment on the side that says, do this, 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 this. And so, yeah, that's kind of the workflow. Hopefully that all made sense. Are there any questions? All right, cool. I'll assume there are no questions. So yeah, and if this is going to be recorded, so you'll be able to look back at this if you need to. But these steps are also mentioned on the contribution guidelines, which is a document that you can find on the GitHub repository. You can find it on the Discord server. You can also find it if you're in any of the documents. All other documents are also linked in the documents. And so if you go scroll down to the how to contribute section, the typical workflow section, there's like a step-by-step process of what I just did. Not step-by-step because I didn't want to put all that in there. But it basically tells you clone first, or you fork and you clone it, and you claim your test and all that kind of stuff. So yeah, that's what you're going to be doing basically. So hopefully that all makes sense. Cool. So we just did this part. And so now I'm going to do some coding work. So for the programmers out there, we're going to implement a very dummy feature. So if there's no questions, I'll just get started. Okay, cool. So, yeah, what we're gonna do is we're going to make a character, make it interact with the floor. So basically, it doesn't just fall through it. We're gonna make it so you can move right and left, and then you can jump. Very basic. But this is gonna teach you hopefully a lot about how your workflow is gonna be when you're making new features. So let me delete this. So the first thing I need, probably a floor. So I'm just going to create to the object. The sprite is an image, and I'm going to get a square. And then I'm going to call this ground. Cool. And then what I'm doing now is I'm pressing Q, W, E, R, T. And so if you look here on the left side, it's just shortcuts for these tools. So what I want is the rectangle tool. So I'm going to press T. So this just actually scale the object. I just want to make it wide because I want some floor. I'll place it down here. If you look at the game view, there it is. That's going to be our floor. And now let me make our player. I'll make it also a square. And I'll name it player. Cool. Oh, and I didn't mention basic scene controls. So what I'm doing to pan is I'm pressing middle click on my mouse and dragging. I think you can also press Alt if you're using a trackpad. If you hold Alt, you'll get this move tool. So you can just left click and hold Alt and drag. That's how I look around. I just zoom with my scroll wheel. Pan with middle click. Yep. So that's basic controls. And so now we have a player and the ground. You might notice I'm just using white boxes. This is where you're going to be doing a lot of the time because programmers are working at the same time as artists. So you might not always have art ready when you're working. And so you can just make dummy art. By dummy art, I mean colorful boxes. And that's what we're going to be working with. And then later on, we can add the artwork. And so this is where you're going to be doing a lot of the time. And so let me just give this square some color so we can differentiate between the floor and the player. Excuse me, sorry. And yeah, now let's give this player some properties. So the way you give properties to game objects in Unity, game objects are anything in the hierarchy, if you remember, is you go over here to the right side and you can add components. Components are basically properties, kind of. You give behavior to game objects. And so what we need to do is we need to first give it a collider, which means it will collide with other colliders. And then we got to give it a rigid body, which basically lets it interact with physics. These are standard Unity things that are implemented for us. Unity has a physics system and it has a collision system for us, and that's what we're going to be using. So first off, let me give it a rigid body 2D because we're working in a 2D game. And so just by doing that, our player now has physics. So if I press play up here, this will basically start the game. Let it think a little bit. A red box fell, or yeah, it fell. It fall. Words. It started to fall because it has gravity. But you saw it fell through our ground. We don't want that. And so to fix that, we can give it a collider. Let's give it a box collider. And we should also give the floor a collider. Cool. Now these two things have colliders. Go ahead, press play again. Dang it. Cool, they collided. Sweet, that's what we want. Okay, next. Let's actually do some coding. So the way you do coding is through C# scripts. If you haven't done C# before, it is very similar to Java if you've done that before. I know a lot of people have done Java, so hopefully that helps some people. So yeah, let's make some C# scripts. So since we're making scripts, we should probably go into the scripts folder. Then you can right click, create C# script. And let's call this player movement. And if I double click this, it will open up your IDE. If this is your first time installing Unity, it's probably going to automatically install Visual Studio. And so that's what it's going to open. I have Visual Studio Code installed. And so that's what it's going to open. But basically, it's just a text editor just to modify your code. So Unity automatically made this these pieces of code for me. And but this is good because this is what we're going to be working with. We need these functions. So basically, standard programming things. We need some variables, and then we need to call some functions. And so for our player, for movement, what do we need? We need speed, so movement speed, and then we need jump speed. So let me declare those variables. I'm going to make these floats. Jump speed. Cool. And now let me go to Unity. Sorry, I accidentally stopped my video. And let me put this property on the player. To do that, I can either drag this into the player's inspector. If I can move this out of the way. Down here, or I can drag it directly onto the player or directly onto the scene. And that'll basically count as a component. There it is. And there are variables that we declared. Since it was public, we can see it in the Unity inspector. Make this private. It would disappear. Let it compile the script. There we go. It's gone. But we want to see it because we want to be able to modify our values. So we'll make this public again. Cool. And so we have our move speed, we have our jump speed. So what we want to do first is let's implement movement. So let me explain what these functions do first. This is kind of explained up here, but start is called at the very start of the game. Game first starts, everything that's in here is going to happen. Update happens every frame. So if you want something to happen every frame, you should put it in here. And so what we want to do is we want to check to make sure to see if the player wants to move. So let's check for input. So the way you do that is you can do an if statement. And then there's a function in Unity called, or a class in Unity called input. And get key. What happened? Oh, I'm having a glitch. Where's in my talent test is not working, but I think that's what it's called. My autocomplete isn't working, so I'm having to rely on my memory. Let's hope I'm right. And so this is going to check to see if the key in here is pressed down. And to pass in a key, we do something called key code. And the key we want to check for. So I want to check for A. So this is basically if the key A is pressed down, this will be true. If not, it'll be false. And then in here, we want to move left. Else if D is pressed, we want to move right. Hopefully that makes sense. So yeah, but let's actually make the player move now. Am I going too fast for anyone? Does this all make sense? Okay, sweet. So now let's actually make the player move. So the way to do that, if you remember me adding a rigid body to the player earlier, the rigid body is the way that you interact with the physics system in Unity. So we need some way to access that rigid body. So there's two ways I'm going to show you. First way is very easy to understand, and the second way is a little less, but it's the way that you should probably do it. So if I make a variable and of type rigid body 2D, they call this RB. This is the name of the component that we added, remember? So that's the type of the variable. So now because it was public, remember we could see public variables in the inspector. If I go back to the inspector and decompose my scripts, we should be able to see a field down here in the movement script for rigid body. There it is. Sweet. And so, but it doesn't have one. So what we can do is go up here to this rigid body property and simply drag it in. Boom. Now we have a reference to that rigid body. So now we can call methods on that class. We can call methods, we can change its variables, we can do whatever. And so yeah, now we have a reference to it. But what happens all the time when you're making more complicated scripts is you're going to be like, oh, I need to work with the rigid body, right? Let me declare it here, continue working, and then I'll go back and I'll test things. But what you'll forget to do is you'll forget to drag it from the actual component into the field. It happens all the time. It happens to everyone. It's very normal. It's going to happen to you probably. But there's a way to avoid it. So what you can do instead, make it private, and just get a reference directly to it as soon as you start in your code. So in start, what you can do is you can do a method called getComponent. You pass in the type of the component. And that's it. That function will go through the components of this game object until it finds the rigid body and it'll return it. So let's store it right here. This is actually shorthand for this .get component, but you don't have to declare this. And so it'll just get the rigid body component and store it directly. So if you know you want a component on this game object, just declare it as private and get it instantly so you don't forget it later on. So this is like the optimal way of doing it. So let me load it up here. Oh, I forgot a semicolon. Oh, dang. In my current internship, I'm doing Go, the language Go, and there's no semicolons in that. So I'm out of practice a little bit. Okay, cool. So it's not there, but I still have a reference to it because getComponent gets a reference to this rigid body for me. Cool. So now that we have the rigid body, let's tell it to do things. So let's get this rigid body and let's call the property velocity. This is the velocity. I don't remember if it's capital V or not. I wish I had my autocomplete. So this is basically a field in this instance of the rigid body. And we're going to be setting the player's velocity. Cool. But the player has multiple directions they can move in, the X and the Y axis. And so we have to set specifically the X axis. And so the way Unity does this is through vectors. Vectors just hold the multiple values. And so for rigid body, for this velocity, it's going to hold the X and Y velocity. So if we set this equal to a new vector 2, we can pass in two values. The first one will be the X value, so to move speed, and the second one will be the Y value. So we're setting the X value to the speed and the Y value to 0. That'll be our velocity when we press A. And we should probably do the same thing. We're moving the opposite direction. But to determine the direction, we can do positive and negative values. And so if you think of a graph, going right is positive, going left is negative, going up is positive, going down is negative. So if we want to go left, we need a negative movement speed. If we want to go right, we want a positive movement speed. And so now with these changes, we should be able to control our player. Oh crap, it was velocity with a lowercase v. Go away, Zoom. Cool. So now if I press play, why is it not working? Oh, okay. I made a mistake. I forgot to set the movement speed. We were setting the velocity to 0, so nothing was changing. Let me put a value in here like 5. Cool. Now if I press left and right, our homie moves. Cool. But we are making, oh, you have a question? Yeah, yo, we have like a game kind of. Okay, so one problem though. Let's lift our homie up a little bit. So when it's falling, its velocity is going to be negative, right? Obviously it's falling. But remember how we set our velocity to 0 in the y-axis? That was fine when it's on the floor. But let's say we're falling and I press right and left as soon as I start falling. I'm going to be moving in the middle of the air. You see that? I like stop for a second and move while I stop moving down while I was moving to the side. I don't want that. So we should do instead is instead of setting the y to 0, let's set it to rb.velocity.y, which basically just gets our current y velocity. It goes to the velocity variable and it checks what the y is and just returns that. And so we're setting the movement speed in the x direction to our velocity, but the y one to our current velocity. So if we're falling, moving left and right won't affect our falling speed. Does that make sense? So now, if I go back here. If I go right and left, I should not affect my falling speed. There you go. You saw it was a pretty smooth fall. That's what we want. Sweet. So now you have simple left and right movement. You've made a game that can be played technically. So that's a big step. So now let's go to the next one. But before I do that, do we have any questions? Does this make sense for everyone? Is there anything you want me to show? Something that I might have skipped over too quickly? Okay, I'll assume we're good. Okay, so next, let's do some jumping. So if you kind of understood what we did here, we're going to do something very similar. We have to check to see if the player presses up. So W. And now we'll jump up. We'll get the velocity, and we'll set it equal to a new vector 2. But we don't want to modify the x velocity, right? So let's do rb.velocity.x, and then set our y velocity to the jump speed. So if the player presses W, we'll set their vertical speed to go up. Cool. So let me pull the homie down closer to the ground. Cool. So now we can. Oh, I made the same mistake again. I forgot to set the jump speed. Oh, something that I completely forgot to mention, that it's kind of important, and this mistake will happen to you all the time. If you're following along with me and you've been pressing play, you might notice that your screen doesn't turn blue like mine. It might turn like light, like a little bit darker gray. I change my settings and like my preferences. Colors. Yeah, I changed my play mode tint to blue, if you look here. So that way it's like super obvious that I'm in play mode, because sometimes you won't notice. The reason is, if I went to my jump speed and I was like, oh, I forgot to set my jump speed. No. And I set this to like, okay, now it's too big, to like 10. Now I'll jump, right? Because I have a speed now. I'll be setting the speed. And I can change this on the fly. So like, I want to jump a little less. There you go. And you're like, sweet, I made my changes. Let me stop play mode and go code again. But I stopped play mode, and now my jump speed went back to 0. That's because during play mode, none of your changes to variables are saved, which is a little bit annoying. but that's just how Unity works. And so that's why I made it super obvious that I'm in play mode so I don't accidentally make changes while I'm in play mode. So it's good to like test the values, but just make sure you write them down or remember them so that when you go back outside of play mode, you can write them down. Cool. That's just a little tip. Let me make an official change to jump speed. And now let's see if our homie jumps. There we go. Cool. But we also accidentally implemented a bug, or at least not a feature that we were trying to go for. What I was trying to go for was a single jump, kind of like Mario. Mario doesn't have a double jump. He just jumps once, lands on the ground, he can jump again, right? But if I just keep pressing W, I'll jump infinitely. Why is that? That's because in my code, the only thing I'm doing is checking to see if the player presses W. I never know when the player touches the ground. So let's do that. So this is something that'll help you, not with just with jumping, but in Unity, you can right click and you can create empty. This is an empty game object, which means it has no properties. All it is a point in space. And that's called this ground checker. This means the player won't see it. It's not visible to anyone except you as the editor. Sorry, excuse me. And so this is very good when you want to place stuff on like a player that's invisible, on like an enemy. You want to give them some properties that you need a separate object for. And so what we're going to do with this is we're going to give it some collider so we can check to see if we're touching the ground. And so to make this easier for us, the editors to see, if you go to ground checker, you go to the inspector, you can click the top here in the top left and select a little icon. This icon only appears in the scene view, not in the game, just in the scene. This way, for you as the editor, you can easily see where all your invisible things are. So you can easily move it around. You can click on it. Very nice. I might make it not red because I want it to be able to be visible when I put it on my homie. Okay, cool. So, but we want this ground checker to move when my player moves, right? What would be the point of putting this ground checker separately somewhere if I'm not going to know where my player is? So what you can do in Unity is you can parent objects. This just means that if I put this on top of the thing I want to parent to, this thing up here is the parent and this is the child. The child's transform, this thing up here, will always align with the parent's transform. So if now I move the parent, the ground checker moves too. When they were separate, that did not happen. This way, if the player jumps, so the ground checker. So let me go to the ground checker and zero out its position. And this position and all the rotation will be relative to the parent's location. So you see it says 0, 0 here. But if I were to unparent it, it would change to these values. These are the world space values, and these are the values relative to the parent. Cool. But the ground checker should probably be near the ground, right? So let me pull this down a little bit. So it's right at the feet of the player. Cool. And now I need some way for this ground checker to know where the ground is. So if you remember before, we used something called a collider to stop the player from falling to the ground. We're going to use the same thing called a, actually, no, we're not, sorry. sorry. That's for something else. So what we're going to do is we're going to go into the script now, and let's get our reference to our ground checker. So let me do public transform, which is that property you saw on the empty game object. The only component it had was a transform, and let's call this ground checker. Cool. And since this is a public variable, we'll be able to see it in the inspector. Let it think a little bit. Let me go to the player. There it is. And then what I can do is just click and drag the ground checker in here. I could also click this plus sign here and look up ground checker. But both ways work. So now I have a reference to this ground checker's transform. That makes sense. So we're going to use that to have a location of like where my feet are or where the player's feet are. That way we can check to see if the feet are touching the ground. So let's do a thing called physics 2D.overlap sphere. Oh man, I wish I had autocomplete. And let's do ground checker dot position. So let me explain what's happening here. Physics 2D is a physics system. We're going to add an invisible sphere around this position. And we're going to give it a radius of 1.5. That's what's happening here. We're placing a sphere with a center at this position and a radius of this. Cool. And what this returns is true or false, depending on whether this sphere has a collider inside of it. So let's store that and call this variable is grounded. So if my player is grounded when this overlap sphere has a collider inside of it. Let's hope I spelled that right. Let's see if I get some errors. God dang it, I forgot. Okay, I'm gonna have to Google this then. You get to see some live debugging. Oh. Wait. Overlap circle. I'm slightly dumb. And let me make sure I have the right parameters for it. Cool. Point radius. Sweet. Cool. Let me see if this works by just simply printing out whenever grounded is true. Oh, wait, sorry. We can just check it straight up here. If grounded is true, and I'm pressing W, then I can jump. Cool, jumping is working, but it's still broken. Why is that? It's because it's checking for any colliders. Do you know what else is a collider? The player. So this overlap sphere is accidentally also checking to see where the player is. We want it to only check to see where the ground is. So that's where layers come in. So layers are things you can give to game objects to differentiate between them. So let's make a ground layer. If you go up here to the properties, you can add a layer. Let's make one called ground. Go back to this dude and add the ground layer. And now we can make sure the ground checker only checks for the ground layer. So first, let's declare a variable up here, call it layer mask, ground layer. That way we can go to the inspector and select what layer we want to check for. Cool, you see this variable here? That's what we just made. We're going to select the layer ground. Oh, crap. Cool. And now this overlap circle can take in an extra parameter, which is a layer mask. And so this means that this will only be true if we're hitting a collider that is also on this layer. If that makes sense. Well, what did I do wrong? Hmm. Oh, I'm dumb. I passed in the word layer mask instead of the ground layer. Okay. Let it think a little bit. Cool, cool. So now, no matter how many times I press W, I will only jump when I'm on the ground. Sweet. So now you have player movement. You can jump once. You can move left and right. That's a player. Look, you go. You made a basic platformer. Cool. We are over the time that I had promised, but I'm going to add one small little helpful fact. Yeah, it is epic. Thank you, Michael. Let me add a little extra detail if you guys don't mind. So if you looked over here at the ground checker, this is really confusing, right? There's an invisible circle around this. How am I supposed to know how big it is, if it's in the right location? This is very confusing, right? So something you can do is called Gizmos. This little blue thing here is a gizmo. It's basically like a icon that is only seen in the scene view. Like this camera thing, that's a gizmo. If you go up here, this is toggling the visibility of all gizmos. I click this, those go away. Like that, it comes back. You can draw your own gizmos through code. So that's what we're going to do. We're going to make a circle around our ground checker. That's a gizmo. That's the same size as the invisible circle. That way it won't be invisible anymore. So over here, outside of update, we can do something called onDraw Gizmos. This is a Unity function that is called when gizmos are drawn onto the scene view. And so whatever you want to be drawn in the scene view, you call here. And so what we're going to do is we're first going to do gizmos dot color equals color dot blue. Why not? We're setting the color of the gizmo we want to make. And then we're going to do gizmos dot draw. Oh, I wish I had autocomplete. Okay, back to Unity. Let's see if they tell us. Here we go. Draw a wire sphere. That's what we want. And this will take in, oh, my internet's unstable. Is the connection still okay for you guys? Can you guys hear me fine? I hope so. Okay, so this draw wire sphere takes in two parameters, the center of the circle and the radius. And so basically the same thing we did up here. We want the ground checker position, I want a radius of 0.5. So now if we save this, and we go back to Unity, and I forgot a semicolon. Why did it not? Huh. Oh, it's lowercase. Okay. Sorry about that. Just some simple debugging. Cool. There you go. There's our circle. There it is. If I move the ground checker, since the center of the ground checker is set to the center, sorry, the center of our ground checker in code is set to the center of this object. If I move it around, the circle also moves around. What I could also do is I could like set a variable up here called public ground checker radius. And then I can set this to a default value of 0.5. I could pass it in here instead of this radius and pass it down here as well. So now both of these use that same radius. What did I do wrong? Oh, I forgot the type. So now if I go to player, I could now, oh, sorry, move you guys. I can adjust this radius and the circle will update too. So now you can visually see what this ground checker is doing. Cool. So now if I press play, and I go to our scene view during play, you can see that the ground checker is on the ground. Sweet. I can actually look at both at once. This is kind of the setup I usually use. So that way you can see the scene view while the game actually works too. So you can see that when I press W and the ground checker hits the floor, I jump. There you go. So that's basically what I wanted to teach you guys today. You now know how to make scripts, how to add components to game objects, how to use empty game objects, how to draw gizmos, and how to interact with the scene view. So yeah, that's the basics of Unity. You guys are Unity programmers now. No problem, no problem. If you guys have any questions, feel free to ask them now. If not, you're free to go. Thank you so much for coming. And I hope you guys make some cool things. No problem. I think we're going for, okay, for the people in the video, Valentine, I hope I pronounced your name right, asked, I'm curious, what type of movement feel are you going for? We're going for, I think, a more snappy movement, similar to Celeste. This game is heavily inspired by Celeste, like Celeste Hollow Knight style, where it's very fast and snappy. I think, like by fast and snappy, I mean you go up quickly and you fall quickly. I think you fall faster than you go up in Celeste. So that's kind of the feel what we were going for. Yeah, and a bit shorter on the jump side, I think. Yeah. Yeah. No problem, no problem. Okay,